welcome. This video will be a full introductory course to the Fastify Node.js web framework. Let's start with an introduction to Fastify. We'll talk about what Fastify is and what makes it different from other similar tools. So what is Fastify? Fastify is a node-based web application framework, or in other words, an HTTP/HTTPS server. It can be used to power RESTful APIs or any other API that is HTTP based. It can also render templates, although not directly, but through its excellent plugin infrastructure. You can use it to server-side render a handlebars template or many other templating languages. It can also, of course, serve static files through HTTPS, and although it doesn't allow database access with the built-in internals as Fastify is plugin-based and extensible, it has plugins for database access for the most popular database systems, such as MySQL, Postgres, MongoDB, Redis, and others. So why use Fastify when there are other Node.js-based web frameworks? In fact, if you remember when you learned Node.js, or if you're learning Node.js right now, the first framework you've heard of probably was Express. And the reason for that is that Express is much more popular than any other Node.js framework. If we look at the Google Trends search interest, comparing Express, Fastify, and two other web frameworks based on Node, Koa and Hapi, you can see that Express is vastly more popular. And the GitHub stars reflect, although not the same, a similar picture. These stats are not perfect and they don't reflect perfectly the actual developer usage of these frameworks, but it shows that Express is much more popular than all other web frameworks based on Node.js. So what makes Fastify better than Express, and in which aspects is it better? The most important ideology behind Fastify is to provide better performance by focusing on the lowest possible overhead on each HTTP request. Let's see why this is important. This is a benchmark with a synthetic hello world request, and it shows requests per second that each framework could achieve when basically benchmarked with many requests. As you can see, Fastify outperforms all other frameworks, but most importantly outperforms Express vastly. While Express could achieve a little bit over 11,000 requests per second, Fastify achieved more than 49,000. Now, this is a synthetic Hello World benchmark. It's meant to show the overhead of the framework on a simple request with a basic response body. It doesn't mean that your API can achieve 49,000 requests per second if you use Fastify, but it means that the overhead is lower and the actual framework is faster. This is the actual aim and philosophy behind Fastify. And while the other frameworks like Koa and Hapi also perform well, their focus is not the maximum amount of performance, which is why Fastify outperforms them. Let's now build an app with Fastify. I have an empty folder opened in my code editor, and the first thing I'll do is initialize an npm project. Next, I'll create a source directory and an index.js file. We'll have to install Fastify as a dependency using npm install fastify. I'll change my node package type to module so that I can use ES6 import syntax. And now I'm ready to build my Fastify app. The first thing I'll do is import Fastify from the Fastify package. And to create a Fastify application, we just run Fastify as a function. It accepts an object of options. And I will actually set the first option, which is logger, that is by default false. Logger, when logger is set to false, you will not see any logs in the console while the application is running, which I don't want for development. So I want to set it to true. I want to see the logs. To start the actual HTTP server, we have to do Fastify listen and provide an options object, which I'll specify the port in. I want my app to run on port 3002. This function can actually fail, so I'll put it in a try-catch block. If it throws an error, I can use the fastify walk function to log an error using the fastify logger, and the walk function has an error method which accepts an error. This is very handy actually. And if we catch an error, I want to exit the program with exit code 1. This will just stop the Node.js application. Now we have created a Fastify server and started it on port 3002. We don't have any endpoints defined. So the first one I will define between the instantiation of the server and the listening will be a get method. Similar to Express and other frameworks, we have a get function attached to the Fastify object. And first we specify the route. In this case, I want to do a get method on the root route. We accept a callback handler with a request and reply objects. And that's a function, of course. And here in the request object, we have all of the HTTP request attributes, including the headers and other details. On the reply object, we have methods which we can use to send back a reply, like reply sent, where we can send a response here. Or alternatively, Fastify offers an even better method, which is to just return an object, for example. And in this case, my object will be message, hello world. Let's now start the server. To do so, I will add a start script, which will be just node source index. That will just start my index file in the source directory. So let's run my Fastify app now. And as we can see, the logger says that the server is listening at localhost 3002. And if I open that in a web browser, I immediately get my JSON response on the root route, which is message hello world. Now this is the most simple app you can build with Fastify. There is also an alternative syntax for defining routes. Let's check it out. It's called Fastify route. The route method accepts an object of properties. The first one, of course, being the method in most cases. In this case, I want a second get method. We also have a URL option where we will specify this route as hello dash. Let's include a parameter as well, which in this case I want to be name. So this route will work under hello and any name parameter right here. In this case, John. It's currently not defined, so I get an error, not found, 404. Okay, so let's continue its definition. The next item we need is the handler, which will be an actual function. Similar, actually the same function structure as in the get function. The get function includes the method as a function, then we get the URL here, and we specify the handler as a third parameter. This is just an alternative syntax for the same thing. We have request and reply, and we can return an object again with a message. And this time I want the message to include my parameter, which I can access from the request object right here. And the request object has a params property that includes all parameters. And I want the name parameter actually. I had a typo there. Alright, if I refresh now, nothing happens because I haven't refreshed my program. I would actually want a watcher for development. To do so, I will install as a developer dependency nodemon, and I will include a second node script which I'll call def, which will just run source index with nodemon. Let's clear and run the def script. Now the same server started the same program, but if I save, it restarts. So now I can refresh and I get my message hello, including my parameter John. If I change that to do, it changes. Now here we have other capabilities. In any handler, it doesn't matter if it's the route or this syntax, we can also define a JSON schema for every part of the request, both the request and the response. We do so under the schema property, and here we can first define a schema for the parameters. We do so by specifying properties, name, and then I can define the required type of name. I can also specify the required parameters, although this is not extremely useful because implicitly your parameters become required as you define the route with the URL parameter in it. So this route will only be accessible if the parameter is provided. Still, we can also define a schema for the response by specifying response. Then the response code, we can specify schemas for different response codes. This is a 200 response code, which is for success, of course. And here we use the same properties. Message of type string. This is how my response is structured. And I can specify required properties again. I would like message to be required. I specify that in an array. So how is my schema helpful? Right now nothing will change basically because everything is valid from the request to the response. But if I don't pass message, for example, in the response, I will get an internal server error telling me exactly what I've missed. Message is required in this case, and I didn't have to do any checks in my handler for that. In many web frameworks, you have to do that manually with code. Here you can do so with JSON schema, which is convenient, and some people really like the syntax, other people hate it. You can make your own conclusions. I think it's fairly concise for what it can achieve in terms of validation. This schema works for parameters, response, as you can see. It also can be used for query string to validate any query parameters. Such query parameters could be type, for example, or whatever. I mean, they are defined. Let's say we have a last name here. Let's say we pass name as one parameter and last name as a second one. So I'll pass John and a last name of Doe. And in query string, I would expect properties of type last name, type string, and I will require them also. What happens now is nothing, but if I remove my query parameters, I get a validation error query string once I have required property last name. If I include it again, my error goes away. And I can, of course, use this property using request query string last name. Let's check that out. Sorry, it's actually request query last name, to correct myself. And we can now read both the parameter and the query string to output a JSON response. And we validate that with a schema. We can use the same schema with the alternative syntax while not using fastify route but fastify get. How we do that is we can pass an options object right here that can include a schema. And this schema can actually be the same format as right here. Makes no difference whatsoever. You can use whichever syntax you prefer and find cleaner. This one is more JSON heavy, this one is more functional, and I personally like the more functional syntax. I think it looks more concise and cleaner. And it's closer to the other code you have in your code base as opposed to a lot of JSON, basically. So this is this is how you define basic routes. You would usually want to have multiple files in order to structure your endpoints into controllers, for example, if you're building a RESTful API. So I would want to separate these two greetings in a separate greetings controller, let's say. In Express, we could do that with a router. Here, we can use a plugin. Let's first make a controller file. I'll call it greetings controller, and it will be a function that accepts three parameters. The first one is the Fastify application server. The second one is the options, and the third one is done. And that's how you define a Fastify plugin. Quite straightforward. You have to call done when the plugin finishes all of its subroutine stuff. And here you have access to the Fastify server. And we can define our routes right here. So I'll copy this one, the first one we made. That just returns hello world. And let me just remove the options because we don't have any. And I'll remove the second route for now. Now I have a route here defined in my controller. How do I register this controller with Fastify? To do so, I will first import the function greetings controller. And to register a plugin, as this function is a Fastify plugin, I just specify Fastify register the function, and then I have a couple of options. I will use the prefix option. This is a URL prefix. I want my controller to be under the greetings route, all of its endpoints. So as my only handler right now is under the root URL, and my entire controller is prefixed by greetings, to access this new route in my controller, let me just see. Okay, I have a syntax error. I have to export this function, of course. So as I was mentioning, here we have defined a controller under the root route, but my entire controller is prefixed under greetings. So to access this endpoint now, I cannot just open the root, make a GET request to the root domain. I have to make a request to the greetings endpoint. And as you can see, my plugin is working. And that's because I've prefixed all of my controller methods with this prefix. That's very useful. In addition, controllers are actually encapsulated. So any modifications you make here to the Fastify server will not have an effect on the main runtime or other controllers. That's extremely useful. By modifications, I mean multiple things for which I'll talk about later, but we can do decorators, hooks, and other things. All right, let's add another method to our controller. We had a method that was outputting a parameter, name parameter, so let's do that as well. It's in request params name. So now this will be under greetings. Let me see. I actually want it under root name so that I can say greetings John, and I get my endpoint, hello John. Now it's recommended to specify at least the response schema. Why is that? Let me first specify the schema object. I can do so as a constant up here because it's just an object. Response schema. Having a specified response schema will actually improve the Fastify performance because it can serialize JSON easier. Alright, response 200, I expect properties, and specifically a message property of type string. Alright. And I can use my response schema in both of my endpoints because they both return a message. And everything is working the same way, except again, if I do not return a message, I will get an empty object because message is not a required property. If I make it required, I will get an error. Let me see. I have a syntax error somewhere. Okay, required shouldn't be in properties. It should be beneath it. Yeah, I get message is required. If it's not required, it will just not be serialized. This is why Fastify will be faster if you specify the response schema. So I would recommend at least specifying that. Although the request parameters, request body is very good to have validated. I would say required. If you're building any API that is used by many users or of any significance whatsoever except training and learning. So this is how you define a controller and also a Fastify plugin and use it. Plugins are not the only extensibility option of Fastify. You can also use hooks. Hooks are code that executes at a certain lifecycle event. In this case, this code defines a new hook that executes on request. This is a Fastify lifecycle event. We will look at a graph of all lifecycle events of a request in Fastify, but essentially, on request is the first hook that Fastify executes after a request is made. And this hook will execute some code which you will specify in place of this comment and then go on with the other code of the request, with the other code of any request in your Fastify server instance. And this will be passed to all subcomponents and plugins underneath this context. Now let's look at the application lifecycle. There are multiple hooks after every step in a Fastify request. This is essentially a single HTTP request that starts with incoming request and ends with an outgoing response. As you can see, you basically have 7 hooks you can use to do anything you want after each step. And the first one is on request that fires after the router and instance logger run. Then you have pre-parsing, pre-validation, pre-handler, pre-serialization on send, and a hook after the entire request finishes. What this hook is frequently used for is, for example, authentication with a JSON web token or attaching a user object after authentication. Speaking of attaching a user object, you would typically, when you do authentication here, whatever authentication with a JSON web token, OAuth, doesn't matter, you would want to usually, in some cases, attach an object of user information to the request so that it can be passed to the next handler, whatever it is. And to do that, we can use what is called a decorator. Here's what a decorator is. Here we have a Fastify hook that executes pre-handler. This means, if you remember the lifecycle methods, that this hook will execute just before the user handler, which is the function we specify to handle the request. And this hook for pre-handler attaches a user object to the request and specifies just a string. But in a real application, that wouldn't be just a string. It would usually include the user ID or the name of the user in some cases if you need it, the user email, or other things. And then it fires the done callback so that the hook terminates. Now, if we look later in the GET request, because we have this pre-handler hook, now in any request, we actually have a user attached to the request, which we do here. And that's exactly what a hook is used for in Fastify. So why do we need decorators at this point? I mean, add hook basically adds this property and we can read it. So why is this first line necessary? Fastify decorate request user empty string. Decorators are used to attach properties, whatever they are, to the native Fastify request object or other object. And they are necessary because if you don't use a decorator here, this will deserialize basically the request object. What this means simply is you get worse performance because Fastify would not know what the structure of the request object is anymore. So in order to do this, you're required to actually decorate your request. That is if you want the best performance, and you should always want it. This is considered just the basic syntax of Fastify. You have to decorate objects in order to add custom properties to them with your data. And that's what decorators are used for. We specify an empty string here to specify to Fastify that this user object on the request will be a string. If your property will be an object, an array, or something else, you have to specify it as null. This is just a specificity that you can read for in the documentation, the Fastify docs for decorators. Let's now talk about data access. Fastify has excellent plugins for data access. One of these is Fastify MySQL, but we also have plugins for Postgres, MongoDB, Redis, LevelDB, and you can find others as well. These are the ones included in the official documentation and some of the most used databases. So let's do a demo with one of these plugins, specifically Fastify MySQL. It's what I've chosen to do a demo with. This is the Fastify application we've been building so far, and here on this computer I have a MySQL server running where I've prepared a simple database. For this example, I have a bookstore DB in my MySQL DB and a books table, which includes just a table of ID, title, and author, and I have 4 books here just for demonstrative purposes. So how do we instantiate and use MySQL, or in fact any basically Fastify plugin? To do so, we have to install it, of course. We will install it with npm, and that's Fastify MySQL. After it installs, I will import it, and we will use the same register function. I'll just add a comment here that this is controllers, database access code, and I'll just do Fastify register, my plugin, and then options for it. Fastify MySQL uses the MySQL to Node module. Here I have to specify the MySQL host, which in my case is localhost, because my server is running on this machine. And I have to also specify the user, which in this case is root, and a password. Okay, I fetched the local MySQL password. You would never store a production password in code. You have to always use an environment variable, a secret, and there are many ways to store a MySQL password or even authenticate your MySQL or database server in other ways. This is not how you do it, except when doing training and learning, etc. This is easier in this case. And this server is local, only for development on this PC, no one has access to it. So this is perfectly safe in this case. And we can specify the database, which in this case is called bookstore. And I will also set promise to true. This will change the entire API of this plugin to promises and not callbacks, which is very handy. Now I've registered this plugin and I can access it in my Fastify object. It's basically accessible under Fastify MySQL now. But to demonstrate its usage, I'll make a new controller, which I'll call the books controller, because the database is a bookstore basically. And again, I'll define a books controller function, which has a Fastify, options, and done parameters. I'll call done and export it by default. Alright, now I will import this controller right here. And I will register it. Just like my greetings controller, I will say books controller, and I'll do the books route, as is by RESTful best practices. And let's register a get endpoint under books that will retrieve all books. This is request reply, and I will basically now retrieve all books. To do so, I will get the response from this has to be an async function, as I'll be dealing with promises in my MySQL plugin. So to access the plugin, I go to Fastify MySQL and we have an execute method. This execute method accepts an SQL query, which will, in this case, will be select everything from books, quite straightforward. And that's it in this case. And I have to await this because it's a promise. And the response is actually an array where the first item will be my books. And in this case, I want to return a reply that will include a books object with all of my books. And that's how we do that. Let me see, I have a syntactic error somewhere. But where is that? Oh, no, not await, an async function. Okay, let's start my server again because it turned it off to install Fastify MySQL. No syntax errors, let's refresh. And now to get my books, I should be able to do so under the books route. And here we go. Again, I need to specify the response schema because that's the best practice. Under 200, no, sorry, first response 200, and then I expect books to be of type array. And here in my handler, I will say an options object with the schema that will be response schema. Okay, let's make a post request because so far we've only made get requests with Fastify just to practice. Post to the same endpoint. I don't need this response schema exactly. Request, reply. In this case, we would want book to be in the request body, basically. And we will make a MySQL request to Fastify MySQL. This time the query will be a little bit different. We'll do an insert into query, that will be books, and we'll insert into title and author, these columns, and the values will be, here we use 2 question marks. The execute MySQL function provides allows us to add additional values. This is important to use because otherwise you're vulnerable to SQL injection attacks. And we will pass the title and the author. Essentially, these values in the array will replace the question marks in the order you provide them and in the order you type the question marks. And this should be a valid SQL query. Now, this is also valid for the first schema. We should have a try catch block, because the MySQL function can always throw an error, any database connectivity, and in case of an error, just return it. It's a returnable object in Fastify, so that will be perfectly fine. Here also, we will do a try catch block, and in case of an error, return it. Otherwise, I will return a status 200 object, just to indicate that everything is fine. Here we will define a schema again. I'll call that post schema, and it will basically include a body validation this time, which will expect the following properties. We want a book object. Let me see. Yeah, a book object in the request body. Book of type object. So book will be required. And the response is quite straightforward. All right. So that should be the post schema. Let me see. I have a syntax error, required book. Yeah, I'm missing a comma. All right. So this is my post request. Now we can test it, basically. To test it, I'll use Postman because it's a post request and that's an easy to test your post requests. Let me close this and make a new post request to my HTTP server, HTTP not HTTPS, books. That's under port 3002. And in the headers, I will include content type. That will be application JSON, of course. and the body will be raw JSON. It will include a book object with title, test book, and with author. That will have the value of test author. Alright, and if I send this request now, I get a status 200. And if I check my SQL client, I've created my book. Now, because I have validation and schema, if, for example, I don't have my book object, I'll get an error, which is pretty great. Besides that, we've created a controller with data access through MySQL, which is great. That's very useful if you're building a RESTful API. With this, I'll wrap this introductory course. We learned what Fastify is, what separates it from other similar tools. We learned how to create a Fastify app, how to create endpoints, abstract away controllers, work with plugins, create a custom plugin, and do database access. We talked about hooks and decorators. These are the basics of Fastify. What makes Fastify great is its extensibility and plugins, which you can explore. There are many plugins which will allow you to do a lot of things. Fastify is very complete and mature at this point, and you can use it for your next RESTful API, ensuring you have optimal performance. If you like the content, please subscribe in order to get updates when the next video is released. Take care.